Welcome back, everyone. All right, let's just dive right into it. Today on The Explainer, we're unpacking the absolute brilliance behind VLANs. If you've ever stared at a massive enterprise network and thought, how on earth do they keep this whole shebang organized, secure, and running smoothly without turning the server room into a tangled nightmare of cables? Well, you're in exactly the right place. We're going to head to the whiteboard today and map out exactly how this tech works under the hood. But to really get any technology, we've got to understand the exact problem it was built to solve, right? So think about this core engineering puzzle for a second. How do you efficiently separate network traffic? We absolutely need isolation between different departments, for security, for performance, but there is no way we're buying massive amounts of redundant hardware or running thousands of miles of extra physical cables. We need logical separation, but over a shared physical space. So here's our roadmap for today. First, we'll look at the broadcast problem. Then, what is a VLAN? After that, we'll go inside the MAC table, tackle multi-switch scaling, and finally wrap up with trunk ports and tagging. All right, part one, the broadcast problem. Picture a standard flat network. We've got one single switch and three entirely different departments plugged right into it: IT, servers, and sales. Because they're all sharing the exact same physical hardware without any special configuration, they're sharing the exact same network space. Basically, they form one big, incredibly noisy broadcast domain. And let me tell you, that flat design quickly turns into a massive headache. Imagine IT PC1 needs to find a printer. It sends out an ARP broadcast, essentially yelling, "Hey, who has IP address 192.168.1.50?" In a flat network, that broadcast goes to literally everyone. IT gets it, the web server gets it, the whole sales team gets it. Every single device has to stop whatever it's doing, burn a little CPU power, process the frame, just to realize, oh wait, I'm not the printer. Now scale that up to, say, 200 plus devices. Every DHCP request, every Windows announcement, it is incredibly wasteful. Plus, you've got zero privacy. A broadcast from one corner of the building is just out there for everyone else to see. Which brings us to section 2. What is a VLAN? VLAN stands for Virtual Local Area Network, and I really want to focus on that word virtual for a second, because it simply means that nothing physically changed in the room. Zero new walls, zero new cables, no extra switches bolted into the rack. A VLAN is quite honestly just a simple configuration on the switch. It's really just the switch keeping a tiny internal table that assigns a number to a specific port, and then it enforces one simple rule based on that lookup. Let's trace a day in the life of a broadcast frame to see this in action. Step 1, ITPC1 builds its broadcast frame, looking for that printer again. Now, crucially, the PC has absolutely no clue that VLANs even exist. It just sends out a standard frame. Step 2, the frame hits the switch, but before forwarding anything, the switch pauses. It checks its internal table and asks, okay, what VLAN is this arriving port assigned to? It sees port 1 is in VLAN 10. So step 3, the switch floods that broadcast frame, but, and here's the kicker, only to other ports that are also assigned to VLAN 10. Because the switch knows ITPC1 is sitting on a VLAN 10 port, that broadcast is strictly contained. It only shoots out to port 2, which is also IT. The brilliant logic of this port-to-VLAN mapping just completely stops the broadcast dead at the boundary. The web server, the sales PCs, they get absolutely nothing. They're left blissfully unaware, saving their CPU cycles and keeping IT's traffic totally private. It's a real game changer. Moving on to section 3, inside the MAC table. Okay, so a standard switch usually has one massive MAC address table to look up where devices live. But the second you enable VLANs, something fascinating happens under the hood. The switch actually takes that single massive table and slices it up into separate private lookup spaces. VLAN 10 gets its own dedicated MAC table. VLAN 20 gets its own. VLAN 30 gets its own. So when a frame arrives on a VLAN 10 port, the switch only searches for the destination MAC inside that VLAN 10 table. The other tables, they aren't even checked. I actually love this quote from our source material because it hits the nail right on the head. A VLAN-aware switch is N tiny independent switches glued together inside one box. The absolute crucial takeaway here is that devices in different VLANs cannot find each other natively, even if they know the correct MAC address. If a sales PC in VLAN 30 tries to force a message directly to an IT PC, the switch looks in the VLAN 30 table, comes up empty, and just drops or floods it locally. The frame literally cannot cross over. All right, section 4, scaling across multiple switches. Now, let's think about a real-world enterprise environment. What if you're running, say, 50 VLANs across your company? The naive approach to connecting two switches on different floors would be to just run a dedicated physical cable for every single VLAN. And sure, mechanically, that works. But financially, practically, it's an absolute disaster. If you have 50 VLANs, you'd burn through 50 physical cables and waste 100 expensive switch ports just to link those two switches together. That kind of setup simply doesn't scale. No way.
Which builds a pretty clear case for finding a better way. The naive approach gives you this tangled, wasteful mess of multi-cable uplinks, like needing 3 separate cables for just 3 VLANs. But the clean, elegant reality of enterprise networking relies on using just one single cable, known as a trunk cable. And this one cable has the power to carry the traffic for all 50 or even all 200 of your VLANs simultaneously.
This takes us to our final core concept, Section 5, trunk ports and tagging.
Once you start dealing with multiple switches, you really have to draw a hard line between two types of ports. First, the access port. This is what we've been talking about so far. It connects to a single end device, like a PC, it belongs to exactly one VLAN, and the frames flowing through it remain completely standard and untagged. A trunk port, on the other hand, is a totally different beast. It connects a switch to another switch, or maybe a router. It carries multiple VLANs all at once, and the frames traversing it, those are tagged. And the actual magic that makes a trunk port work comes down to just 4 bytes of extra data. That's literally it. When a frame needs to cross that shared trunk cable, the sending switch injects a tiny 4-byte label right into the frame header. This label is known as an 802.1 Q tag, and it essentially just holds the VLAN number that the frame belongs to. Let's follow a frame one last time to see the whole process. An untagged frame arrives at switch A from an IT computer. Switch A realizes, hey, the destination is over on switch B, so it routes the frame out the trunk port. As it's leaving, switch A inserts that tiny 4-byte 802.1 Q tag that says VLAN 10. The frame zooms across the physical wire. When it arrives, switch B reads the tag, says, okay, this belongs to VLAN 10, and then strips the tag completely off. It forwards the now untagged frame to the destination IT PC. Those end devices, they never even knew the tag existed. So let's just quickly recap this awesome journey we've been on. We started out with a noisy, flat broadcast domain that wasted CPU cycles and had zero privacy. We fixed that by essentially turning one physical switch into multiple virtual switches, using isolated MAC tables based on super simple port assignments. And then we figured out how to scale the whole thing elegantly across multiple floors using a single trunk cable and those magical 4-byte 802.1 Q tags. Which leaves us with one massive, lingering question to ponder. By implementing VLANs, we've basically built perfect, soundproof walls around our different departments. But what happens when a PC in the IT VLAN legitimately needs to configure a server over in the server VLAN? We've engineered this brilliant system where they absolutely cannot talk to each other. VLANs are walls. So how do we get through the wall? Well, that's going to require connecting our Layer 2 switching to Layer 3 IP addressing through something called inter-VLAN routing, and that is exactly what we'll be covering in our next explainer. Thanks so much for hanging out and learning with me today.